All right, folks. Mr. T's sick. So rare. I think this is my first sick day at Blanchette. But not 100% here, but I'm going to guide you through a little bit of this. We'll try to keep it nice and short. Be nice to your sub, get your work done, and let's jump into it, huh? All right. So we have been talking about this problem for a long, long time. Long, long time. We got these ITBS scores, Gary, Indiana. Um, but let's say we don't let's look at the graph. Look at all these terrible numbers. Your mean is 6.84. One standard deviation away is 5.29. Two standard deviations below is 3.74. Those aren't numbers people are going to normally look for, right? If this was like AP test, no one's going to be like, hey, did you get a 2.75 on your AP test? No, they're going to say, did you get a 3? Did you get a 4? So a lot of the time, standard deviation doesn't give us numbers we want to end or start at. And so we maybe want to find what's the probability that's a randomly selected seventh grader scored less than 4. Okay, because then maybe it's like, okay, we need to do some kind of intervention with this group, or how are we doing against another school or another state? And 4 is like a more reasonable number to try to do. So unfortunately, though, if we want to pick a nice number like 4, our 68, 95, 99.7 rule does not work. Okay. So then that rule does not work. So we got to do something else. And uh, I'm going to show you what we're going to do. Okay. So the 68, 95, 99.7 rule, we've done a lot with. You know how to do it, but it's not always practical because you get weird numbers. So instead, um, we're going to use other ways to find those areas. Okay. One thing you always want to do, and we talked about this a couple of times ago, draw it, guys. You really want to draw it. You want to draw it, you want to label it, you want to scale it, just so you can clearly see what kind of area you're actually trying to find. Okay. And again, if I'm going through too fast through these, feel free to pause and take a look and write this stuff down. None of you are probably writing, like probably two of you are writing stuff down. I appreciate the two of you, but I do think these are important. You just got two little things I'm going to talk through. Okay, so draw it just so you can see what area you're trying to capture of the normal distribution. Okay, step two, there's two parts here. So I'm going to show you how to do both of these. So then we're going to calculate the area. One way we can do that is we can standardize the boundary values, okay, and turn them into z's. Okay, we're going to turn them into z values, and then we can use the z table to find the desired probability area. Okay, so we're going to take the boundaries. Sometimes, like the one we just looked at, this is just one boundary because we just want x less than 4. So we only have to do z, find the z value once. But if we had the probability of something like this, where x is in between, oh my God, look at that 5. That was something. Where x is in between maybe 5 and 7, then we're going to have to standardize two things, and we're going to have to look up two things on the z table. Okay? Not that that's that hard, but I'm just telling you that that's how it works. Okay? So that's the first way we're going to learn how to do it, and you need to know how to do it by hand for your quiz next week. Okay, we're still having a quiz. Mr. T's not here. We're still having a quiz. You better believe it. And then the second is we're just going to use our calculator. Okay, your calculator can do this stuff pretty easy breezy. So I'll show you how to do that. That is the plan. I'm going to show you how to do both of those. Let's just roll through it. And then you got a little worksheet your sub's going to hand out. Be nice to the sub and do your worksheet. Okay, there's just 6 problems on the worksheet. So let's try it. So we're going to go ahead and we're going to standardize by hand. Okay, so we're going back to our ITBS students. Okay, we want to find the probability that x is less than 4. Again, let's give it a little draw. That's terrible. It's absolutely terrible. Let's get a little steeper because it was kind of a steeper one. Oh yeah, now we're talking. And then we had 6.84. Look at that straight little dotted line. We're really doing well here today, folks. So we got 6.84 is right down the mean. That looks a little better. And then our standard deviation is 1.55, so we could add those in, and you should add those in. Okay. Let's just see where the bottom one is. So it was, I can't do math right now, 5.29 and 3.74. Okay. So I'll put those ones in. This one was 5.29. We had like 3.74. So we want to find that x is less than 4. Okay, so let's change color here. So 4 is like going to be right here. So we're going to want all the area to the left of that. Again, we're going to have to now use our z-score to help us find that. Okay, so we want 4 as our value now. So remember, z is value minus mean divided by standard deviation. So here we go. So we got 4 minus 6.84 divided by 1.55. That's going to go ahead and give us our z-score that we want to look for. Okay. So I'm going to use my phone calculator. I don't seem to have another calculator. So we got 4 minus 6.84. Okay. So we get negative 2.84 on top. Do. Then we're going to go ahead and divide by 1.55. So if that worked correctly. Hold on. Momentito, muchachos. Yeah, there we go. So we get negative 1.83. Okay. And you want to go 2 decimals because that's how far z table goes. Okay. So we get negative 1.83. So now we got to go over and we got to pull up the z table. Okay. So here's the z table. And we got negative 1.80. 1, 2, 3, 4. So it's 0.03288. 0.03288. You can see my terrible face there. I apologize for that. I apologize for that. Okay, so it's 0.03288, I think was what it was. Remember that Z table is on Google Classroom. Okay. So that is how you would find that area. All right. That is how you would find that area. Now, again, we talked about this problem. If we wanted to be between 5 and 8, we would need to do a z-score for 5. We'd need to do a z-score for 8. We'd have 2 z's. Should we call them z1, z2? z1, z2. And you would look up both of those on the table. You do the biggest one minus the smallest one, and that would give you your range. Okay, and that one's going to look more like this, where it's we're somewhere like 5 to 8, and we're finding this middle area. Okay, so you got to subtract the bigger one minus the smaller one when you get one where there's one on each side. Okay, so that's how you calculate your area by hand using z-scores. Okay, it's not that bad. You guys have done z-score before, and then you just use the table and you look it up. So you just standardize the score, look it up, and do that. Okay. Cool. Should we do it with the calc? Do we have another example? What do we got here? Okay, so we can also use it doing a calculator. Okay, so and it's so easy, so easy. I don't know why we're talking about this again, but just remember Z is value minus mean divided by standard dev, everybody's fave, everybody's fave. So here's a weird thing, okay, that you got to kind of just flow with me on, So when you're putting these into the calculator, okay, you want to do so many standard deviations above or below the value you're finding that you're basically getting to uh like the value that you want. Remember, the tail in the standard deviation can go super far, like it never technically reaches zero. So we're picking a lower bound. If we want the probability that X is less than a number, we're picking a lower bound of 1,000 negative standard deviations to try to get as much area to the left of the number we want as possible. If we want that X is greater than a number, our upper bound is going to be 1,000 standard deviations above whatever number we have, okay? Because we want to try to find uh all that area to the right. So we're just kind of doing 1,000 standard deviations, which would, never happen, but never say never. If you have a number that X is in between, then that's really easy. Easy, you don't really have to worry about the bounds being 1,000 or negative 1,000. You can just put in the two numbers. So that one will be easier, but you gotta have to remember that these bounds are negative 1,000 and positive 1,000. Okay? So let's look at a problem here. We're tired of the ITBS scores. I think I have another funner problem. Yes. So X is the distance the golf ball travels. Randomly selected shot hit by Rory McIlroy. Rory. Okay. Suppose that X follows a normal distribution, so his mean drive is 304 yards, and the standard deviation of those drives is 8 yards. Let's find and interpret the probability that he drives more than 290 yards. So now you got to get out your calc. It's got to be a graphing calculator, okay? So let's take a gander here. Actually, let me check my notes 1 second. Just remind myself I'm doing the right thing to show you. Okay. So let's get the calc up. Don't look at my face. I'm sorry. Okay, so what we're going to do to find this is we're going to go second vars. Okay, that brings up this thing called distribution. Guess what? We're on distributions. Now there's two different ones here. You got a normal PDF and a normal CDF. We want the normal CDF. Okay, so we're going to take the normal CDF. Okay, what did we want? Oh boy. We wanted uh that he was greater than 290. Okay. So that means our lower bound is going to be 290, right? Because we want him above 290. And this is where you go upper. Okay. You put 1,000. Now our standard deviation, I think we were at 310. Or sorry, our mean was 310 and our standard deviation was 8 yards. I think that was correct. We want to find what's the probability he drives more. Was that it? 310? 304. Sorry. The mean was 304. So we're going to put in 304. So his mean was 304. His standard deviation was 8. What's the probability then that the drive is more than 290? You go down and you hit paste. And there's your normal CDF with all of our stats. And we get the chance that he drives more than 290 on any random thing is 96%. Okay. So let's go back here, 96%. This equals 96%. Okay, let's do another one where we find an in-between. So let's say, what's the probability his drive is between 300 and 310 yards? How about that? So let's say, what's the probability he's in between 300 and 310? So go back to the calc. Okay, we're gonna go again. It's second vars to bring up the distribution, and we go number two, which is normal CDF. We want to know, Rory, what's the chance you're between 300 and 310? And our mean and our standard deviation don't change. So we go boom. And he's got a 46% chance that he is in between 300 and 310. Okay. So there you go with that one. So it's 46%. So that's how you use the calculator. Again, you go second vars, normal CDF. We want the CDF one. All right, we got one more problem to do. So we can also work backwards to find where a certain percentile is using the calculator. This one would be harder to do by hand. I mean, it's possible, but it'd be a little harder to do by hand. Oh boy. All right. So according to the CDC, the heights of 3-year-olds are normally distributed with a mean of 94.5 centimeters, a standard deviation of 4 centimeters. 75% of 3-year-olds are taller than what height? Okay. So now we want to go back to the calc. So it's 94.5 and 4. So we're going to go back to the calculator. I don't know if I have to keep stopping the share or if it'll just actually do it if I just change. I'm not sure. So I'm sorry if I keep doing that and I don't need to. Again, we're going to go second vars to bring up distribution. But now we're going to go to number 3, and 3 will help us work backwards. So we're going inverted normal. Okay. I would always just keep your tail to the left. You're going to know how many people are to the left um, of your deal. Okay, so we want to take up 0.75 area because we want to know how tall a kiddo is if they're, no, we want the other way, right? We want to know, well, let's look at the question again. 75% of 3-year-olds are taller than what height? So actually we want 0.25 here, right? Because then we know 75% of 3-year-olds are taller than the bottom 25 percentile. Yeah, so Mr. T was wrong. We actually want to put in 0.25 here because then we know 75% of 3-year-olds are taller than this 25%. And this is going to give us the height of those 3-year-olds. And would we have 94.5, I think was it? And then the standard dev was 4, if I believe. I would always just keep your tail left and you can think of it like kind of how I thought of it there. Um, but you can mess around with that and just be careful. Okay, so we get 91.8 centimeters. So, 75% of 3-year-olds are taller than 91.5 centimeters. Is that what it was? 91.5? 91.8, sorry. 91.8. Okay? Which makes sense. 75% of 3-year-olds are taller than 91.8 centimeters. Our mean was 94.5. So that would be 50% of 3-year-olds are taller than 94.5. So it makes sense it goes down to get more people included in that 75%. So that is how you work backwards, folks. What an honor it's been. Thank you for watching this. I hope you did. And thanks for sticking in with me. Sorry I wasn't there. Last new material of the year. I'm very sad to miss it. But do your worksheet. Send me an email if you got any questions. Thanks. Hope you have a good one, everybody.